Hello, students. We are into 8.1 mathematical connections. Math connections here, 1 through 3, 6, and 8, and 9. So what we've got is someone writing things in an algebraic way. Students were asked to write algebraic expression for the sum of 5 consecutive natural numbers. One student wrote x plus, let's see here. We've got x plus 1, x plus 2, x plus 3, x plus 4. So every time they're adding one number. Okay, so that makes sense. And then they summarized it here. Another wrote x minus 2, x minus 1, x plus 1, x plus 2, and got 5x out of it. Yeah, it just says for the sum of 5 consecutive natural numbers. So maybe both of these students are correct. Obviously, they had a different starting point. One person picked the middle, one person picked the beginning. Okay. So the smallest, one person picked the middle number. I mean, you almost could write more expressions in this depending on where you pick your starting number. Okay, then it asks, so explain who is correct and why. Does either approach prove the sum of 5 consecutive integers equals 5 times the middle term? Well, I mean, the second one here looks like I get 5x as my result. The middle term was x, so I really could make that connection here. But to be perfectly honest, maybe up in this first one where it says x plus 2 is my middle term, the end result is 5x plus 10, and I could use that beautiful factoring property. And notice, here's my middle term, and this turned out to be 5 times the middle term. So it, once again, seems like it shows that, even though it doesn't show it maybe as explicitly. Does the statement in part B generalize to the sum of 5 consecutive terms in every arithmetic sequence? So now you have to determine whether this works for every arithmetic sequence or just the ones that we're referring to here. Let's see here. Choose 7 consecutive terms, any arithmetic sequence. Check the arithmetic average. That's adding all the terms up, dividing by 7. Does that equal the middle term? Prove it. Now in part B, you actually have to go through and prove it. So when you do your proof, it doesn't matter which way you start. Make sure you're justifying why is this the case. So no one could come up and say, aha, I've got a counterexample. You need to make sure you've proven it for every possible case. Now, number 3, you'll notice looks very similar to a problem we did before. I want you to practice this one. What did the teacher do? Write it out algebraically. Show how you simplify things algebraically and how the teacher could figure out the original number very quickly. What would the teacher have to do? The teacher is not going to do all of those things. The teacher is using algebra to make things shorter and easier. So that's 1 through 3. We've got 6 and then 8 through 9. So 6, these are connecting math to the classroom. So we've got Joel saying there's no reason to have more than one type of formula. Why don't I just have one type? It should be explicit or recursive. Okay, you have to now respond. What do you think? Could we have a different type of formula? If you're wondering, what does that actually represent? A explicit formula for the nth term in an arithmetic sequence looks something like this. I would need the first term, how many terms, and the common difference. However, if I was just thinking, how do I get from one term to the next, I would have what is known as a recursive formula. And what this says is to find the next term, take the term you're on and add a common difference, and you'll get to the next term. So this one is explicit, and this one is recursive. Maybe there are good reasons to have each type of formula, and maybe it's not a bad thing. But I'm going to leave that for you in your explanation because you are the future teacher. Let's see your question 8. A student wants to know how she can prove a sequence whose nth term is 5n plus 4 is arithmetic, and a sequence whose nth term is 5 times 3 to the n over 2 is geometric. How would you prove that if you just know the nth term, how do you prove that it must be arithmetic? Okay. And how would you prove the other one is geometric? Okay. And how would you talk to that student? Not just about how do you do it, but how do you talk to the student about that? Right? What kind of questions would you ask your student? Question 9. Rosa brought a puzzle from Facebook. It's a Facebook puzzle. Now that is pretty cute, isn't it? All right, so she said, how do I solve this? How do I use variables here? So maybe you can demonstrate how you could solve it with variables, and perhaps you could demonstrate how maybe I don't need variables to solve a problem like this. All right, that wraps it up. That's it. I know, 8.1. Done and dusted. All right, well, I hope you have a great rest of your day. Off you go.